In this module, we'll take the eIDAS 2.0 wallet-based onboarding model and turn it into a concrete Azure architecture. We'll choose services for APIs, compute, data, identity, and messaging, while balancing scalability, compliance, security, cost, and operational complexity. You've already done the hard thinking, understanding eIDAS 2.0, the wallet actors, the requirements, and the regulatory controls that shape your design. You also define the target architecture and flows. Now we translate that blueprint into specific Azure services, so every capability has a clear implementation path. Service selection starts by asking, what must this KYC platform actually do? You need capabilities like verification, orchestration, evidence storage, audit, trust checks, manual review, and downstream integration. Only then do you map Azure services to those capabilities and stress test them against latency, resiliency, data residency, and compliance evidence. Avoid chasing shiny new services when the workload is early stage or low criticality. Capture your reasoning so you can defend choices in design reviews and audits. Think of this architecture as a layered platform for wallet-based KYC. Clients first hit API management or application gateway, which expose and protect verifier and onboarding APIs. Those calls are processed in the compute layer by app service, AKS, container apps, or functions, with durable functions coordinating long-running flows. Customer data, evidence, and documents live in SQL, Cosmos DB, PostgreSQL, or blob storage. Underneath, Entra ID, managed identities, Key Vault, HSM, and private endpoints provide the security backbone. This API and integration layer is the secure digital front door to all KYC capabilities. Every wallet interaction, onboarding status check, or partner request must pass through it. Application Gateway with WAF blocks malicious traffic, while Azure API Management enforces authentication, throttling, and schema validation. Policies handle IP filtering, JWT checks, and detailed logging. Only after these controls are satisfied do you call sensitive services or external integrations like AML, sanctions, and trust registries. Now picture your platform as 3 zones of exposure. At the public edge, you only expose what wallets and relying parties need, such as onboarding or presentation request APIs. Behind that, an application private zone hosts relying party and operations APIs, reachable only from trusted networks. Deepest inside, a data and security zone keeps SQL, blobs, keys, evidence, and queues on private endpoints. Even in this core, every call is authenticated, authorized, and logged. Next, treat each KYC capability as a workload with a different lifestyle. Long-running web APIs and orchestration layers often fit best on app service. When you need maximum control, custom networking, or a full microservice platform, AKS is the natural home. Container apps give you many container benefits without Kubernetes complexity. And functions shine for short bursts of work, callbacks, trust checks, notifications, and simple integrations that must scale instantly. Verifier and orchestration services act as the control tower for wallet-based onboarding. The verifier focuses on protocol, handling OIDC4 VP requests, calling trust services, and validating evidence. Orchestration then chains these steps with AML and KYC checks, updates customer profiles, and captures audit trails. You choose app service, container apps, or AKS based on latency, scale, and security needs. For complex, long-running flows, durable functions keep waiting, retries, and manual reviews reliable and traceable. Treat your KYC platform as several distinct data problems, not one giant database. Customer state, workflow status, and decision records benefit from strong relational structure and transactions, which makes Azure SQL a natural home. If your teams favor open source, need JSON alongside relational data, or want portability, PostgreSQL fits well. For rapidly changing schemas, globally distributed session data, or spiky read and write patterns, Cosmos DB shines. Match each data type to the store that best fits its behavior. KYC evidence also lives through a governed lifecycle. First, you capture items like consent, verifiable presentations, screening results, and audit logs. You classify them, encrypt them, Then store them in Azure Blob Storage with versioning and immutable options where needed. Keep evidence content separate from metadata so you can search and secure them independently. Finally, apply retention, legal hold, and defensible deletion rules aligned to GDPR, AML, and your internal policies. Identity is the front door to the KYC platform. Microsoft Entra ID governs people and applications, while managed identities handle authentication for Azure services without storing secrets. You separate human access, workload access, CI/CD pipelines, and break glass accounts. Then apply least privilege across each path. Role-based access control, conditional access policies, and privileged identity management together ensure every action is authorized, time-bound, and fully auditable. Wallet-based KYC only works if your cryptographic foundations are boringly predictable and well-run. Put every secret, certificate, and key into Azure Key Vault or managed HSM, never into code, repos, or pipeline variables. Define who can use keys versus who can administer them, and log every access. Automate certificate issuance and renewal for APIs and MTLS. Then enforce rotation, expiry alerts, backup, and tested recovery so a lost key never becomes an outage. Real-world onboarding rarely runs as one long synchronous API call. Each stage publishes messages or events that other services react to when they're ready. Azure Service Bus handles durable work, queued onboarding jobs, manual reviews, retries, and dead letters. Azure Event Grid fans out lightweight state change events. This decouples verifier, KYC, AML, evidence, notifications, and downstream systems. Correlation IDs and consistent event schemas tie everything into a traceable end-to-end audit trail. When you're choosing between logic apps and durable functions, think about who builds and maintains the workflow. Logic apps shine for low-code integration, SaaS connectors, approvals, onboarding steps, and case management, where change is frequent and business users need visibility. Durable functions are better when developers need code-first orchestration, long-running, stateful flows, or sophisticated retries and branching. Whichever you choose, let workflows coordinate state and use messaging to decouple systems and absorb spikes. You've now seen how to turn a wallet-based KYC design into concrete Azure services mapped by capability: APIs, compute, storage, identity, keys, messaging, and workflow. Carry this mindset of trade-offs and clear boundaries into the next steps, where we'll design deployment and network, then deepen security, privacy, and operational readiness.